All right, so today our essential question or our goal is that the student will be able to use the focus and directrix in order to write the equation of a quadratic or parabola. So they're making the parabola shape. So the first thing we need to know is what a focus and what a directrix is. The directrix is a fixed line used to define. So the directrix is this line that sits outside of the parabola. So if your parabola opens up or down, it's going to either sit below it or on top of it. If your parabola opens left and right, the directrix is going to sit to the left of it or to the right of it. Okay, the focus of a parabola is a fixed point used to point. So we've got directrix is a line, focus is a point. The point is inside of your parabola. So it's inside. The directrix is outside, the focus is inside. Now, the distance between the vertex and the focus is called the focal length. And we use the letter P to describe this. So your distance, and it's the same, the distance from the directrix to the vertex is the same as the distance from the directrix to the focus. So this spot here, from the directrix to the vertex is P, but so is from the vertex to the focus is P. So you've got your P value if you know where the vertex or the focus or the directrix is. Same thing if your graph opens the other direction. From the directrix to the vertex is P, but you could also find that value going from the vertex to the focus. Okay. If your graph opens up or down, then you're going to use this formula to write the equation. If it opens up, you're going to use a positive p-value. If it opens down, you're going to use a negative p-value. If your graph opens to the left or right, then you're going to use this equation. If it opens right, then you use a positive p-value, and if it opens left, you use a negative p-value. All right, so example 1. Write an equation for, that should say, the graph of a parabola with a vertex 3, -2, and a directrix y equals -1. So my vertex is 3, -2. That's here. If my directrix is y equals -1, that's here. Remember, the directrix is always outside of your quadratic, which means this quadratic has to open down. If it opens down, we're going to follow this first formula. So x minus h squared equals 4p times y minus k. Okay, hk is the vertex. Let me write this a little bit smaller. Okay, so the vertex form. So we need HK, and we also need P. HK is our vertex, and our vertex was given at 3, -2. Okay, P is a negative number because our graph opens down, and it's 1 because the distance in between the directrix and the vertex is 1, okay? So if I know that, I'm just going to fill in the formula. So we had x minus h squared equals 4p y minus k. Okay, so when we fill in our numbers, we've got x minus, our h is 3 squared equals 4. Our p is -1. Y minus k is -2, but if I subtract the -2, it becomes plus. Okay? Now I'm going to multiply 4 and negative 1. So I have parentheses x minus 3 squared equals negative 4 y plus 2. Okay, that's the vertex form. If I want to rewrite that same equation in standard form, then I just need to multiply everything out and make it. So remember, standard form is when you've got ax squared, bx, and c. So you just need to multiply it all out. So we're going to take this over. We've got x minus 3 squared equals negative 4 y plus 2. First, I'm going to do the x minus 3 squared. It's the same as x minus 3 times x minus 3. So if you FOIL that out, you get x squared minus 6x plus 9 equals, now distribute the negative 4 4y minus 8. Now, I need to solve for y because it's the value, or it's the variable that doesn't have a square on it. So I'm going to add 8 to both sides, which means I'm going to add 8 to the 9. So x squared minus 6x plus 17 equals negative 4y. To get the y, we're going to divide everything we have by negative 4. So I end up with y equals, this is a 1, so negative 1/4 x squared plus negative 6 over negative 4 simplifies to a positive 3/2 x. And then 17 over negative 4 is just negative 17 over 4. So this is the vertex form, and this is the standard form. Okay? I'm going to do this second example in a second video.